Hello, Cloud Gurus. Let's talk about scaling up your applications. At some point, you're going to need more horsepower for whatever applications you're running for your company. You might need to go from running just one web server to 100 or even 1,000 web servers. And Kubernetes can make this super easy to do. For a little bit of background on how this works, Kubernetes uses deployments to do this. Deployments provide reliability, ensuring that a specific number of pods are always running. They provide load balancing because when you create a service, inbound connections will automatically be distributed across the pods running in the deployment, and they provide scaling. So you can easily reconfigure a deployment to run a higher or lower number of pods. When you create a deployment, it creates what they call a replica set. Now, you might find some documentation out there that talks about replication controllers. Replication controllers have been replaced by replica sets for the most part, and it's recommended that you only use replica sets. And that's what a deployment will automatically create for you. The great thing about deployments is that they use that declarative model, so you can have a YAML file that documents the pods and services and storage and policies that you want to bring up in your Kubernetes cluster. You say kubectl apply -f, point it to that YAML file, and that's exactly what will be created for you. And you have that documentation. You can take that YAML file anywhere else, run it in Kubernetes, and the exact same thing will happen. Deployments also allow you to perform rolling upgrades or updates. So when you need to update your application and run a new version of the application or a new version of the web server or database server, deployments make that possible with zero downtime. So we said deployments create replica sets. Replica sets are used to maintain a specific number of replica pods running at all times. And that replica set will actually add or delete pods as necessary. So if a few pods die for whatever reason, the replica set will add more pods, 2 more pods, to ensure you're always running the exact number that you specified. If somehow too many pods are running, the replica set will get rid of pods or kill off pods to, again, make sure you're running the exact same number of pods that you specified. And while you can easily create a replica set, it's recommended that you use a deployment to manage the replica set instead and let the deployment create the replica set for you. And now let's talk about another type of controller, and that is a daemon set or daemon set, however you want to pronounce it. I usually say daemon set, and if you think that's wrong, forgive me in advance. A daemon set is used to ensure that the same pod is running on all nodes in the cluster and that pod is started before other pods. So in Linux, you typically have daemons or daemons that run at all times, and these are kind of system services. Over in Windows, you have Windows services that run at all times. The daemon set Kubernetes controller was created for exactly this purpose. And this is great for logging or management agents that need to run on every node in the cluster. Another type of controller that you need to be aware of is the stateful set. Stateful sets are designed to run stateful applications, and in doing so, they maintain a sticky identity for each of the pods. This is really ideal for applications that need stable network identifiers, persistent storage, ordered deployments, and automated rolling updates. Now, since this is a fundamentals course, we don't really have time to go into how to create every one of these different controllers. We're going to primarily focus on deployments, but it's important to know what all these different controllers are and how each one has its own individual use case. I encourage you to use the links that I've placed in the resources section for this module to learn more about controllers. When it comes to scaling up your applications, you really have 2 ways to go about it: the declarative model and the imperative model. With the declarative model, you would go back and edit that YAML file that you created, that manifest file that documented what you wanted to run, and change the number of replicas to scale up your application. And then you would use kubectl update to update the deployment. The other way to go about it is to use kubectl scale. For example, we'll do kubectl scale deploy to scale a deployment, provide the deployment name, and then the number of replicas that we want. And it's even possible to do auto scaling. with the kubectl autoscale command. We won't go into that, but it's really cool that this is even possible to scale the number of replicas or pods in your deployment based on the load that this application is under. So if we do kubectl get deployments, you can see we have 3 deployments out there. Let's take the web 1 deployment, and if we do kubectl describe deployment web 1, you can see here by default, the replicas are configured at just 1. 1 is desired, 1 is currently updated. There is 1 in total, and there is 1 available. There are 0 unavailable. Kubernetes is very clear when it comes to replicas. And if we clear the screen, let's use that kubectl scale command to scale our deployment called web1, and we're going to do -- replicas equals, and let's say instead of 1 web server, we wanted 10 web servers running. And it says we just scaled our deployment. Let's do kubectl get deploy. You can see it says the deployment has been scaled. It now says 1 out of 10. If we do kubectl get pods, you can see there are now 10 web servers running, and get deployments, now we have 10 out of 10. So that's how easy it is to scale up your applications in Kubernetes. What if you wanted to scale back down? Easy. Let's go back down from 10 down to just 2. And now we'll do get deployments -w. And oh, it's too fast. It's already happened. We have just 2 pods running. So those other pods were very quickly terminated. And now we just have 2 web server pods running. As you can see, scaling in Kubernetes is super easy to do. I hope you'll join me in the next lesson.